Hey guys, welcome back. In this video, I want to talk about one of the main concept that is related to the advantages of OFDM. So, does OFDM increases data rate or spectral efficiency? So, this is the question. So, this could be even asked in interview as well. Let's say if it is increasing the data rate, how exactly it is increasing the data rate? Okay. Uh, but the reference here is with respect to single carrier system because OFDM is a multi-carrier system, right? So with respect to single carrier system, is it really improving the data rate? That is the question. So after discussing the design of various blocks that are required to build the OFDM system, now we will look into this our major advantage. Okay. So I have taken, the example of the bandwidth to 10 megahertz, right? Okay. So if we are dividing this 10 megahertz bandwidth into multiple subbands, and we have seen that these subbands can be called as the subcarriers, and finally we can see that the spectrum would look like this, correct? In the frequency domain, there would be multiple subcarriers and to mitigate ISI in case of 10 megahertz bandwidth when the symbol duration is very small, we actually went to that subband concept, right? So with this subband concept, what we had seen is in one of the videos, I think part 6, where we had seen that where we had seen the concept of OFDM grid or one OFDM symbol. So one OFDM symbol represents the stacking of subcarriers along the frequency domain, right? And T symbol will be the symbol duration that corresponds to 1 by delta F, which is a subcarrier bandwidth. Because the example which I had taken here is, the 10 megahertz with symbol duration zero point 0.1 microseconds. This is corresponding to single carrier, whereas this one would be, the 4G, where I am dividing this 10 megahertz into 10 kilowatts subband. Each symbol duration is 10 microseconds. So, which means that each of these subcarriers are having 10 kilowatts in bandwidth, and the symbol duration will be 10 microseconds. So based on this, let us see. Okay, so first I will take a single carrier system. Single carrier system, what I have considered, the bandwidth is equal to 10 megahertz, which means that my symbol duration is equal to zero point 0.1 microseconds. Now what I will do, to calculate the data rate. So I will try to stack up. Okay, how does it look like? Let's say this is zero point 0.1 microseconds, one symbol. So here in the y-axis, the bandwidth is 10 megahertz. Okay, so one symbol will occupy the complete 10 megahertz, and it is transmitted, for a duration of symbol duration zero point 0.1 microseconds. Like that, there will be symbol number 2, and it goes on. Let's say if I'm going to take 10 microseconds as the duration, then how many symbols would be there? So 10 microseconds, zero point 0.1 microseconds, right? So around we will have 100 symbols. So first symbol, second symbol, and like that we'll have 100 symbols. So now let's say each symbol is transmitting just one bit, then in which case, what is the data rate? I will just take the data rate for the duration of 10 microseconds. So 100 symbols, each carrying one bit, let's say 100 bits per, I will just not mention the unit because I've taken the reference just 10 microseconds. We can say just 100 bits. Okay, I can say 100 bits per 10 microseconds. So now I will go to this multi-carrier system, which is OFDM, right? So in OFDM, what have we done? We have divided this, and the bandwidth of 10 megahertz into multiple subcarrier bandwidth. That is 100 kilowatts, right? which means that for this complete 10 megahertz, how many subcarriers I will have? I will have 100 subcarriers. But what is the symbol duration? So symbol duration in this case is 10 microseconds. So now if I take this 10 microseconds, one one subcarrier, okay, one subcarrier is actually having the symbol duration which is equal to 10 microseconds. But like that we have 100 subcarriers. We are going to actually multiplex 100 subcarriers in this same duration with this OFDM concept, right? So which means that, see, this one particular subcarrier here, if I see, this is just 100 kilohertz, right? Like that at 200 kilohertz there will be one more. So like that for the 10 till 10 megahertz, we will have total 100 subcarriers stacked up in the frequency. Here, if you see, these are all stacked up in the time domain, but here, these are all stacked up in the frequency domain. Basically, it's like multiplexing, and since we are multiplexing in such a way that we are able to recover this at the receiver, right, um, without any problem with respect to intersymbol interference. So if I consider each subcarrier is carrying one bit, okay, so in the same 10 microsecond duration, how many bits I would be? 100 bits, because each subcarrier 1 bit, we have 100 subcarrier, total 100 bits per same 10 microseconds. Can you see here? Both of them are giving same data rate, okay, but one thing to note down here is, see, each of these subcarriers is not called as a symbol here. The entire multiplexing of 100 symbols, we each of them, each of the subcarrier having a duration of 10 microseconds. This entire thing is called as one OFDM symbol. Okay, this is just one OFDM symbol, but since the amount of information transmitted in one OFDM symbols is equal to 100 bits per 10 microseconds, because one OFDM symbol consists of 100 subcarriers, whereas the single carrier system, if we talk about number of symbols, actually here we have 100 symbols. Okay, so 100 symbol versus one OFDM symbol, that difference, I think you got it right now. So I hope you got the clarity, why the data rate we are getting same. So by that way, even we say that the spectral efficiency is also same. Okay, but then where is the data rate increasing in case of OFDM? See, in OFDM, what did we do? We divided the subband. I mean, we divided the entire bandwidth into subbands, right? That has helped us to increase the symbol duration to 10 microseconds. With this 10 microsecond, I mean, this is becoming larger, and hence this is helping us to overcome that delay spread, which will be of the order of just 2 microseconds to approximately 5 microseconds, right? So since we have increased the symbol duration, um, we have actually brought down the intersymbol interference to a greater extent. So uh, but in case of single carrier system, if you want to support this 10 megahertz, then what we had seen in earlier videos is that we are having a huge intersymbol interference. I mean to say, up to 20 symbols are getting intersymbol interference, right? So whereas in this case, it is restricted to only one symbol, one OFDM symbol. Even with the CP addition, which we saw in the previous video, we were able to completely eliminate the ISI, right? Because of this reason, what I would say is, in earlier generations like the 3G, 1G, 2G, 3G, we are not able to go beyond certain data rate because we are not able to increase the bandwidth. Because the moment we increase the bandwidth, we were susceptible to multipath fading effects, and we were seeing a huge ISI, and we were not able to recover the symbols at the receiver. But the moment we go for multi-carrier system with the concept of OFDM design, it has given the flexibility to go beyond the supported bandwidth, right? Okay, so let's say 1 to up to 3G, the supported bandwidth was maximum, let's say 3 megahertz. Okay, approximately I'm telling the 3 megahertz, but or less than or equal to 3 megahertz, let's say. Okay, but in case of 4G, we were able to break this barrier and go beyond this one. So we had even 5 megahertz, 10 megahertz, 15 megahertz, and up to 20 megahertz. So since we are able to increase the bandwidth, we were able to get better data rates. Okay, so that is the reason in case of OFDM, we say that OFDM concept increases the data rate. Okay, the data rate increase is coming because of the fact that it has helped us to mitigate the ISI when we increase the bandwidth. By that way, it has favored us to go or to have a flexibility in increasing the bandwidth, right? Even in case of 5G, we are further increasing the bandwidth from 20 megahertz to up to 400 megahertz. That I will come in the upcoming videos, but I just wanted to mention for the sake of completeness. I hope you got the clarity, uh, right? In terms of for how whether it increases the data rate or not, and if it is increasing the data rate, how is it increasing? This also I think we got it. Major advantages, yeah, this could be asked in the interviews, right? What are the major advantages? Okay, see, in terms of data rate, if you are telling with respect to single carrier system, it is really not giving much benefit, but the increase in data rate coming into picture because of OFDM helping us to support higher bandwidth. Okay, that is one major advantage. So because of this OFDM concept, having the subband concept, it has helped us to mitigate ISI to a greater extent, and with the CP addition in the OFDM, we have reached zero ISI actually, and by this way we can say that it has helped us to mitigate the multipath fading effects, right? That is another advantage. So then what are the other advantages? See, since we have eliminated the ISI to a greater extent and almost to zero, the receiver complexity is very low. Okay, very simple receiver we were able to develop with OFDM system. But okay, of course, there will be questions like disadvantages as well. With the concept of OFDM, there were many disadvantages like high PAPR issues, and of course, we had many overhead. Like even in case of CP, right? To eliminate this ISI, we added CP, but it has decreased the data rate a little bit. But this overhead is okay for us, and even we wanted to, I mean, even increasing the bandwidth as brought challenges in developing some of the filters, wideband filters, right? And even we had challenges in developing the filters which are having very less roll off. We had challenges there as well. So by considering the roll off, we had to leave out some bandwidth at the edges. Okay, like something like this. So uh, if you see this particular diagram, even though I consider 10 megahertz as the bandwidth, considering the filter roll off for the low pass filter, the edge bandwidth of around 1 megahertz on either side, we had to uh, we had to make it zero so that we don't transmit anything there, right? So like that, we have disadvantages, but mainly I think you got the concept related to what are the advantages. and how it is actually not decreasing the data rate when compared to subcarrier spacing, and how that is actually helping us to flexibly increase the bandwidth, which is further helping us to increase the data rate. So with this, I will wind up this video. Thank you very much. If you are looking for more videos, please do subscribe to the channel. Let us see the further design aspects related to OFDM in the upcoming videos. Okay, bye bye.